Okay, we're going to write an equation for a rational function, which means that it's going to be a function where the variable will be on the numerator and denominator of a fraction. And we are given the vertical asymptotes, the x-intercepts, and the horizontal asymptote. And the fact that we have a horizontal asymptote at y equals 4, or just a constant value, other than 0, uh, that tells you that the degree of the numerator and the degree of the denominator are equivalent to each other. So that's something to point out about horizontal asymptotes. Okay, so that I'm referring to this right here, the horizontal asymptote at y equals 4. Okay, so notice that the vertical asymptote has to do with the denominator and um, the solving the denominator equal to 0. So from that, we can look at the factored form of the denominator and build our denominator. So we have y equals, and the horizontal asymptote, first off, that is the part that's probably the easiest to recognize. Because the horizontal asymptote is at y equals 4 and it's a constant value other than 0, then that tells you that that is going to be the leading coefficient in front of the fraction. So we would have a 4 out in front. And then we would multiply by a fraction. And okay, so the vertical asymptote I was mentioning, that's the denominator, and setting the denominator equal to 0. And one way of thinking of that is we would have the factored form, because we have x equals negative 6 and x equals 4 as our vertical asymptotes. We have two separate parentheses, set of parentheses, being multiplied together. And we would have x minus one of the vertical asymptotes. We'll do negative 6. And we have x minus the other vertical asymptote of 4. Okay? And then we also have the numerator. The numerator has to do with the x-intercepts. The x-intercepts. And so when you set the numerator equal to 0, then you can solve for the x-intercepts. So the first one, similarly, we can set this, set it up the same as the denominator. And the x-intercept of x equals 2, we can set that as x minus 2. Very similar to how we deal with the vertical asymptotes on the denominator. And the other x-intercept of x equals negative 2, that's x minus a negative 2. And now, as I was mentioning before, it may not be too obvious of where I was discussing how we would set the denominator equal to 0 and then solve for the vertical asymptotes. And then for the numerator, we set equal to 0 and we solve for the x-intercepts. I just want to show that really quickly in just a moment. Let's simplify this a little bit more. And then we would have x minus 2, x plus 2, x minus a negative 2. And then similarly, we would have x plus 6 and x minus 4. Now, as I was mentioning, here's our function. We're actually done now, but I wanted to slightly explain where I was discussing how you would solve for the vertical asymptote by setting the denominator equal to 0 and solving for x. Notice that if we were to take this denominator, and I'll do this off to the side, and to solve for the vertical asymptotes, so the vertical abbreviated VA, vertical asymptotes, we would set the denominator x plus 6, x minus 4, and we'd set that denominator equal to 0. That's what I mentioned before. Now, in order to solve for that, we would set both factors, x plus 6 and x minus 4, both equal to 0, and solve. and that's where we get the opposite sign. X equals -6, x equals 4. And this, I could do the same thing for the x-intercept on the numerator. But notice that's the information that was given to us. So it's just working backwards if we were to solve for the vertical asymptote, if we were given the equation. But if we were given the vertical asymptotes, then we can work backwards using this logic and find our equation for our rational function. Okay, so anyways, just a quick explanation of that little part about setting equal to 0 and where I was getting that from. All right, let me know if you have any questions about anything I discussed here. I'm more than happy to break things down in further detail if needed. Yeah, I'm more than happy to help.